Hey all, today we're going to continue talking about sampling distribution models. Last time we talked about distribution of sample proportions. So if we took a bunch of samples, all the possible samples from a population, and we found a proportion of some parameter of interest, and we put those onto a distribution, we said they'd be approximately normal. Um, and we were able to use that information to answer questions and solve problems. And so today we're going to talk about what happens if you get a bunch of samples. So we have a population. Let's say our population of interest is the student body here. And we want to take all the possible samples of sample size, let's say 40 students, all the possible combinations of 40 students. We sample 40 students, and then we sample 40 more, and 40 more, and 40 more, until we get all the possible combinations. Of course, that's impossible. We don't have time for that. It's unreasonable. But if we did, and we found the, let's say, grade point average, the average GPA from all those samples, so the average GPA of a group of 40 students, and then another average GPA, and another, and we plotted those, and we put them on a distribution, you would see that they would turn out to be approximately normal as well. And that idea in statistics we call the central limit theorem. Some of you might have taken calculus or might be taking calculus. There's this thing called the fundamental theorem of calculus. We won't get into that here, but they refer to this central limit theorem as the fundamental theorem of statistics. So if we keep taking the average of a random sample, we will get a distribution of sample means that's approximately normal. The larger the sample size, the closer it is to being a normal model. So when we talk about assumptions and conditions in a minute, we are going to want to be aware of our sample size. We want to take a large enough sample. And so when we had a distribution for sample proportions, let me do like a little quick recap. For proportions, we would have a normal model with the mean being the population proportion P. I'm sorry if you can hear the bell. And the standard deviation of that normal distribution for sample proportions would be PQ, the square root of PQ over N. And so now for means, we can say the mean of a distribution of sample means is going to be the population mean. And the standard deviation is going to be the population standard deviation divided by the square root of the sample size. And so we use these to describe our normal model. We will have something that's approximately symmetric, unimodal, with a mean of the sample mean, or population mean, and the standard deviation is this population standard deviation sigma, that's what that represents, divided by the square root of n. Again, n is the sample size. Before when we were collecting samples and we were putting sample data onto distributions, we had some distributions that were approximately symmetric, some that were skewed left, right, unimodal, bimodal. It doesn't matter if we take a sample of students, to stay with that example. If we take a sample of 40 students and their GPA is not approximately normal, if it's skewed, if it's bimodal, it doesn't matter. If we take the average of that group and then we take an average of another group and the average of another group and we take the means from all those groups and put them on a distribution, it will still turn out to be approximately normal. So if we're going to use this information to answer questions and solve problems, we need to make sure that we establish these assumptions and conditions are true. It's very similar, almost exactly the same as for proportions. We need to always make sure that we are sampling using random methods to eliminate or reduce bias. We need to make sure that every individual in the sample is not affecting another individual's probability of or not influencing them, I'll say. They need to be independent. And if we can't establish their independence, then we at least need to make sure that we are sampling less than 10% of the population. And then when we had proportions, we needed to establish we could use a normal model by doing n times p and n times q. Well, we don't have p's or q's when we're talking about means because we're not talking about proportions. What we need to do is establish that our sample size is large enough. Typically, um, a sample size of 30 or more is good. The smaller your sample size, the more it's going to be important that your sample is actually symmetric. So I just said a minute ago that your sample distribution from your one sample doesn't need to be symmetric. But if your sample size is small, you're going to want your sample to be distributed approximately normally. Um, if you want me to clear that up a little bit, just make sure you ask me, and we can talk about that a little bit more. 30 is usually 30 or more is usually a pretty good amount. So here we're talking again about our female students at a large university. They talked about BMI. They collected data in like height and weight, and so they have this information again from the CDC, and they have some old data or some previously collected data that says the mean weight for an 18-year-old woman, so somebody that would be in college, is 143.74 pounds. They have a standard deviation there of 51.54 pounds. And so those pieces of information, that would be what we would consider our population mean and our population standard deviation. So I like to document those things. And remember, we have a random sample of 200 women, so N is 200. They took those 200 female students and they got their weights. They got an average of their weights, and they said out of those 200, the average was 140. So that's a sample mean X bar. And so what we want to know, similar to what we talked about last time, we want to know if that's unusually low. So last time we talked about, was the proportion of students with a BMI of 25 or more unusual? So we want to know, is this sample mean weight 140 pounds? Is that sample mean weight of the 200 female students, is that unusually low given the CDC's information here that the typical average is 143.74 pounds with a standard deviation of 51.54. So uh, if we were to keep collecting samples of 200 female students and getting their sample or their sample mean weight, we could put all those mean weights onto a distribution and it should be approximately normal. We don't have that kind of time or resource, so we are just going to see if we can approximate it with a normal model without doing all that. So we will see if we have the assumptions and conditions met. Just like last time, we have a random sample of 200 female students. For the sake of time for this lesson, I'm going to sort of just jot down that we meet these criteria. But as I talk about in class and as you do practice, you should write them up in full sentences and be more professional about this. So we have a random sample of 200 female students. So we meet the random sample criteria. I think as we talked about last time, 200 students is less than 10% of the student body at a big college, a big university. And because that is true, we can say we can consider them independent. So we can consider each student's weight, independent of all the other students' weights, because this is less than 10% of the student body. And the last thing we want to establish is that our sample size is large enough. So as I said, 30 or more is usually a good amount. So 200 is greater than or equal to 30, and so our sample size is large enough. And the thing that that tells us is that a normal model is appropriate. That means that if we were to keep sampling 200 females and getting their mean weight, that we would get a distribution of sample means that's approximately normal. But we want to save ourselves the time and just say, yep, that's big enough. This would work. So we can actually draw this distribution. And remember, if I'm going too fast, make sure you pause. You can rewind. You can rewatch. You can listen first, then copy this stuff down. So I'm gonna pause here, and I'm gonna put my distribution on here. So I wanted to figure out what is the mean and standard deviation of this distribution of sample means, my 200 female students and their mean weight. So the mean of this distribution is going to be the population mean that the CDC reported, 143.74. And we calculate the standard deviation of this distribution by taking that standard deviation the CDC gave us, 51.54, and dividing it by the square root of our sample size 200. So that's where I got those numbers. I simplify that to get a standard deviation for our distribution of sample means is 3.64. Typically, your population standard deviation and this sample distribution standard deviation can get a little confusing. So if you need a little clarity on that, just give me a shout, and I can work with you on that. So then I put my mean in the middle, and then I added 3.643 times, subtracted 3.643 times. This isn't the most beautiful thing in the world here. It doesn't have to be. The picture is helpful. And then I want to put on here my sample mean. We were told that the sample of 200 female students had an average weight of 140, so that's somewhere about here. And we want to know, is this sample mean unusually low? Anything that's above 2 standard deviations above the mean, less than 2 standard or lower than 2 standard deviations below the mean, if we're outside of these boundaries, there's my 2 standard deviation boundary. You can see that the curve gets smaller. It's less likely for that to occur, and so we would consider those data points unusual. Our sample mean is just slightly more than 1 standard deviation below our population mean, and so it's not unlikely, it's not unusual. This could happen a lot. If we kept sampling 200 female students, it wouldn't be unlikely to get a sample average of 140 pounds or something close to that. So no, we would say no, this is not unusually low. Okay, 2 standard deviations above or below is sort of the cutoff point. If we get any further away from the mean than that, it's less likely that that will occur, and so we would consider that an unusual sample mean. So as I said last time, if you do have questions, write them down or raise your hand and ask me for help. I'm glad to have a whole class discussion if we need to. I'm glad to work with you individually. Just make sure that you get your questions answered before you practice. Glad to do it. Good luck.